Day 1, Problem 1. Part A, rewrite the number into standard form. To do this, I'm going to write down this number in scientific notation. And to change from scientific notation into standard form, I'm going to use the exponent on the 10 to manipulate this decimal point. When the exponent on the 10 is positive 3, that means that the number 9.05 is going to be multiplied by 10, and then 10 again, and then 10 a third time. And each time you multiply a number by 10, it gets larger by moving the dot one position to the right. And so if the exponent on the 10 is 3, that would mean to move this dot 3 spots to the right. 1, 2, and 3. The decimal point is going to end up here, and this spot is going to get filled in with a 0. And that will create the number 9050, and then the decimal point. So 9,050 is equivalent to 9.05 times 10 to the third power. Part B, rewrite the number into scientific notation. And so we're going to take this pretty large number and rewrite it so that it has scientific notation. I'm going to start by copying that number down, 505, and then 7, and then 00, and 000. And the decimal point right now is at the end. So this number is 505,700,000. What is this rewritten in scientific notation? Well, in scientific notation, instead of having several numbers to the left of the decimal point, we want to have only one number to the left of the decimal point. That means we want to put the dot here so that only the digit 5 is to the left of the dot. So let's move this decimal point to that position and count how far we move it. 1, 2, 3, 4, 5, 6, 7, 8. 8 spots. And so rewriting this number, it will become 5 point and then 057. It's not necessary to write these extra zeros down. And then times 10. And the exponent on the 10 is the number of spots that we had moved the dot, which was 8 spots. This exponent is an 8. So 5.057 times 10 to the 8th power is the scientific notation version of 505,700,000. Okay. Now, day 1, problem 2. Part A, solve this equation. And here's the equation with the variable n. So we'd like to solve that equation and find the value of n. And then in part B, check our answer. Okay. So part A, I'm going to begin by copying that equation down. And next, draw a vertical line downward from the equal symbol to separate the left side of the equation from the right side of the equation. And solving this equation means to isolate the variable to get the letter n alone. And I would like the letter n to end up on the left side of the equation and some number to end up on the right side of the equation, and that number would be the solution for n. I notice there is an n term here, but there's also an n term here. I'm going to remove this n term. So underneath the negative 2n, we're going to write add 2n. And the same on the other side of the equation, add 2n. 3n plus 2n is 5n. Now the plus 1 can be brought straight down, is equal to negative 2n plus 2n makes 0n, or just 0 in this position. And the positive 16 can be brought straight down 16. So we now have the equation 5n plus 1 is equal to 16. Again, we're trying to isolate the letter n. Here is the n term. Now next to the n term there is a plus 1, and we can remove that plus 1 by subtracting 1. And on the other side of the equation, subtract 1. The 5n comes straight down. Positive 1, subtract 1 makes 0. There's a 0 in this position. And that is equal to 16 subtract 1 is 15. And so now we have the equation 5n is equal to 15. We want to get the letter n alone, so let's remove this 5, which is being multiplied to the letter n. And we can remove that 5 using division. So divide by 5, and on this side, divide by 5. 5 divided by 5 makes 1n, and that is equal to 15 divided by 5 is 3. But 1n is just the same thing as n. So n is equal to 3. This is the answer that we think is correct for n. Now in part B, we're going to check whether n really does equal the number 3. So back in this original equation, we think that if we put a 3 here, and we put a 3 here, and then work out what this expression and this expression equals, that they will in fact create the same thing on the left side and the right side of the equation. Let's find out if it works. So 3 parentheses, and then for n, let's fill in the answer that we think is right, and then plus 1 equals, now over here, negative 2 parentheses, for the letter n, fill in 3, and plus 16. So does this expression to the left of the equal symbol really equal this expression, which is to the right of the equal symbol? 3 times 3 is 9, then plus 1. And does that equal negative 2 times 3 is negative 6, and then plus 16. 9 plus 1 is 10, equals, and negative 6 plus 16 is 10. 10 is equal to 10? Yes, it is. This checks, and that means that n is equal to 3 is the correct solution to this original equation.